This video is a conversation between me and one person. And that one person whom I have a conversation with changes moment by moment, but it is always with one person. In my life, over and over again, I have come back to the same question. When is it time for me to let go? I feel that I hold on to people, things, ideas very, very strongly, and I sometimes have a hard time letting go of them. But over and over again, I have found that it is very important for me to let go, for my sanity and for other people's sanity, but also because it brings me so many gifts. This video tells a story of how I learned to let go of many people, ideas, and situations that I held on to so dearly in the past few years. But it is also a video about a very beautiful idea in math. And these two things are actually very related. This video is made up of 3 different stories. One of the stories is about this one math question that I thought about for over a year, but it is, I think, at the heart of so much of the beauty that people talk about in math. It has comforted me many times, and it still continues to comfort me. And believe it or not, the only piece of math that you need to understand it is how to multiply and divide numbers. There are 2 other big parts to this video. The second part is about 3 commitments in a relationship which meant so much to me, and which I decided to say goodbye to. And finally, the third part is about what I have experienced so far trying to fit myself into math education and academia, and my hopes that I can have a different kind of future with math than the ones that have been presented to me. My hope is that by sharing these stories, I can hear some stories of your own that may or may not be related, and hopefully keep a kind of conversation that I think is very important to have open. I have been working on this video for over 2 years now, and I actually have a 50-page long script for this video, but I'm choosing to not rely on a script and just narrate this video entirely off the top of my head, because I want it to feel unfinished, and more importantly, I want it to feel like a one-on-one conversation. So I ask that you also try to see this video as a conversation with me and try to imagine yourself being in front of me. And if at the end of this video you would like to share what you have to say with me, I would love to read it. Oh look, here you come. I'm glad to see that you were able to make it to this cafe. Here, I got a cookie for you. Let's go find a more comfortable spot to chat. Let me start this by asking a kind of silly question. Who is math to you? I really want to show you who math is to me. So let's get started on a really fun puzzle. I hope you have fun. Let's say that you have 2 different sizes of square tiles. One is orange and another is black, and the black one fits inside the orange one exactly like this, where the corners of the black tiles lie exactly on the midpoints of the edges of the orange tiles, like this. And let's say that you're trying to build a square room where the floor is tiled with these black tiles, kind of like this, and the ceiling is tiled with the orange tiles. So to give an example, here are the floor and the ceiling tiles kind of overlaid on top of each other. The black ones are the floor tiles and the orange ones are the ceiling tiles. You'll notice that if our square room is this size, so it's like 4 black tiles long and 3 orange tiles wide in the ceiling, then we're going to need to cut off all this red space, because we need the floor and ceiling to have the same area. Otherwise the walls will be slanted or something weird. So here's the question, and this question is going to set us forth on a really wonderful journey. How big does the room have to be so that we can get the floor and ceiling tiles to line up with each other without having to cut any of the tiles? I encourage you to think about that on your own. So there's kind of one crucial fact that we can realize just by knowing that the black tile fits inside the orange tile like this. And that is that the black tile has exactly half the area of the orange tile. And you could actually see it very neatly in the picture. Since these are the midpoints, I'm going to just circle the midpoints. That means if we cut the orange tile in half with a knife like this, then that cuts the orange tile into two pieces that are exactly the same. And again, if we cut it with a knife like this, then these pieces are the same. And now you'll notice that the black edge actually cuts this orange piece exactly in half. So this is 1/2 of this piece. This is 1/2 of this piece. 1/2, 1/2. So we've split the orange piece into 4 pieces and then taken only the halves of each piece. That must mean that this black tile is exactly half the size of this orange tile. So this doesn't tell us too much right now, but it gives us a way to check if our guess about the size of the room is right or not. So let's say that we guess that like 4x4 grid of black tiles on the floor and a 3x3 grid of orange tiles in the ceiling, maybe that will line up. One way to check is, okay, let's just draw out the tiles. Here we have the floor and the ceiling. We know that for the floor and ceiling tiles to line up without any cutting, another way to say that is that the areas of these are the same. So let's check that the areas are the same. We know that each of these ceiling tiles have exactly the same area as 2 of these floor tiles. So I'm going to cross out each tile one by one. So this one ceiling tile has exactly the same area as these 2 floor tiles. These 2 correspond to this one. These 2 correspond to this one. These 2 correspond to this one. Okay, I think you're starting to see what's happening. Oh no, we have come to the end. We have shown that there's a one-to-one correspondence between each ceiling tile and each 2 floor tiles. But unfortunately, if you have a 3x3 ceiling and a 4x4 floor, then the areas won't match up because there's this one last piece missing. And of course, this kind of one empty piece that is missing corresponds exactly to this red area over here. Okay, so maybe you could check a bunch of different ratios, like maybe, I don't know, like 10 and, or 6 and 4, 5, like just looking at this picture, it doesn't work. You could check and do this kind of correspondence and you'll realize it doesn't work. So, okay, it'll take forever to kind of figure out how to do this. So what do we do now? Well, don't be too sad. This question might be a little bit hard, but when we have a hard problem, it helps to look at an easier problem. Let's say that instead of the black and orange tiles that have this relationship with each other, let's think of red and blue tiles that have this relationship with each other. Namely that these are both kind of made out of the same building block tile. This one tile is the same area as this one tile. And the red tile is made up of a 2x2 grid of this building block, and the blue tile is made up of a 3x3 grid. Let's say that the floor is tiled with the red ones, the ceiling is tiled with the blue ones. How big does the room have to be if it's a square room so that the floor and ceiling line up and you don't have to cut any of the tiles? Here's one answer. 3x3 red tiles and 2x2 blue tiles. That has exactly the same area, and you can actually check with this same idea of this kind of one-to-one correspondence. But now we might wonder, why do they line up? What's so special about this kind of ratio? What I find really cool is that this grid that we've put together They might look different if you draw them with red tiles versus blue tiles, but they're both really the same thing as a 6x6 grid of mini building block squares. The special thing about 6 here is that it can split up into groups of 2 and also into groups of 3. What this means is that what you can do to the columns is split them into groups of 2. So I'm going to group these 2 columns together, these 2 columns together, these 2 columns together. And the same with the rows. You can group them into groups of 2, like this. And what this actually gives you is it gives you exactly this grid right over here. And just like you could do that with groups of 2, guess what happens when you split it up into groups of 3? So group these 3 columns together, these 3 columns together, these together, these together. Then what you end up with exactly is the ceiling tiles. And it's kind of clear now, there's nothing really special about 6. It could have been 12, 18, 24, so on. The most important thing is that it can split up into groups of 2 and also into groups of 3, because that's what's secretly behind this relationship. So I really like this because it gives us everything we need to be able to answer the question fully. Let me just ask one more question. In this problem, how many different kinds of tiles did we have as compared to in this question? Here, to me, it's kind of clear. There's one tile, the red tile, blue tile, and also this kind of secret small tile that's unifying them together. So there's 3 different tiles involved. Meanwhile, in this one, I only see 2 tiles being involved. There's the black tile and the orange tile, and I don't really see that kind of secret tile unifying them together. Well, what if there was that small secret tile unifying the black and orange ones? We just can't see it in this picture. Here are the orange and black tiles placed side by side. Now, if there is a square building block that the orange and black tiles both share, then the orange tile has the same area as a grid made up of that building block. And same with the black tile. It also has the same area as a grid made up of that building block. Now, we don't know exactly how big these 2 grids are, because we don't know how big that building block is in the first place. But just to think about what would happen if we knew how big it was, let's say that the grid that has the same area as the orange tile fits P building blocks from one end to the other. And the grid that has the same area as the black tile fits Q building blocks from one end to the other. That means the orange tile has the same area as a P by P grid of building block squares, and the black tile has the same area as a Q by Q grid. And of course, since P and Q are just numbers, P times Q is also just a number, so you can have P times Q things. So let's put P times Q building block squares end to end, and then just build a square room that has the same area as a P times Q by P times Q grid of building block squares. Now, this square room is very special. Since this square room has the same area as a P times Q by P times Q grid of those building block squares, we can split up that grid, very similar to the way that we split up our 6x6 grid. P times Q splits into groups of Q, so we can split up the big grid into Q by Q grids, just like how we split up our 6x6 grid into 2x2 grids. And since a Q by Q grid has the same area as a black tile, that means that the floor of our room can be tiled completely by black tiles without needing to cut any of them. And this is the exciting part, since P times Q splits into groups of P as well, we can also split up the big grid into P by P grids. And since a P by P grid has the same area as an orange tile, the ceiling of our room can be tiled by the orange tiles without needing to cut any of them. So we did it! We answered our question! We found this room that is exactly the right size, that it fits the black tiles and the orange tiles without having to cut any of them. Now, all we need to know to actually build this room is exactly how big that building block square is compared to the black and orange tiles. Right now, we just thought about a hypothetical, but if we can really find how big this is, then we have the answer to our question. So where do we even start with trying to find how big this building block square is in the first place? Well, the one piece of information that is relevant here is that all of these tiles are the same area as a square grid. Even though we don't know any more specific details than that, that does point us in one direction. We can look at patterns that we notice within square grids themselves. So let's just look at square grids in general. All I've done is draw a bunch of square grids, and I want you to tell me if you find any patterns in the number of tiles that these are made up of. Well, we know that this is made up of 9 tiles in total. This is 16, 25, 36. This is a 3x3 grid, and it has a total of 9 tiles. Both of these numbers are odd. This is a 5x5 grid, it has a total of 25 tiles. These numbers are also both odd. 4 and 16 are both even, 6 and 36 are also both even. Maybe this is a pattern that repeats. Actually, there is a very nice way to show that this pattern actually does repeat. So let's look at an odd numbered grid. So I'll just look at the 5th one. If you look at one of the rows of an odd numbered grid, you'll notice that there is always a middle piece. It always has to have this middle piece, because an odd number is always one more than an even number, which means that the total number of tiles here and here is an even number. Even numbers can be split in half, which means that you can always choose a piece, like the one we highlighted, for whom the number of pieces to its left is the same as the number of pieces to its right. Same goes with columns. Columns should always have a middle piece. So that means that an odd number grid should always have a very centerpiece. You'll notice that an odd number grid always has this tile in the center. This is a very special tile. The number of squares to the top of this middle piece is exactly the same as the number of squares to the bottom of this middle piece. The number to the left should be the same as the number to the right, and you'll notice that the number of squares in this top right corner should be exactly the same as the number of squares in the top left. And same here as well. So if you count the total number of tiles excluding this middle piece, you'll have an even number, because every tile comes with its pair. This one with this one, this one with this one, and so on. Which means that this is an odd number, because there's this one more tile. So yes, if a tile has an odd number of squares in a row, it should have an odd number of tiles in total. Meanwhile, let's look at the even numbers. If the number of tiles in a row is an even number, you should be able to split the row into 2 perfectly half pieces. Same with the column, you should be able to split it perfectly down the middle like this. And now, since you've split this perfectly in half, the total number of tiles here is exactly the same as the number of tiles here, which is the same as the number of tiles here and also here. So you can see if a square grid has an even number of squares in a row, that means in total it should have an even number of squares. So I'm just going to call these guys odd grids, and I'll call these guys even grids. And it's pretty clear that if you have a square grid, it has to be either an odd grid or an even grid. And that's kind of because if you have any number, it's either odd or even. There's no like in between. So let's now return to our scenario. Now I'm going to ask a very devious question. We know that if we build a room with the same area as a p times q by p times q grid, which is made up of the building block square, then that room can perfectly fit both the black and orange tiles in its floor and ceiling without us needing to cut any of them. We know this is a square grid. Is it an even grid or an odd grid? We know it has to be one or the other, so which one is it? Let's try to figure this out together. Our main goal is to figure out if the p times q by p times q grid of building block squares is even or odd. So let's start with what we know about this grid. We know that we can regularly group together the rows and columns of our grid of building block squares in at least 2 different ways. We can turn our grid into a grid of black tiles and into a grid of orange tiles. I've drawn them both here. And of course, both of these have the same area. Now, here's a slightly different question that might help us. Is the grid of black tiles an even grid or an odd grid? If it is an even grid, then we also get the answer to our question. the p times q by p times q grid has to be even as well, since the total number of building block squares is the number of building block squares that makes up a black tile times an even number, which has to be even. Now, luckily, this seems to have a straightforward answer. We know that the orange tile is exactly twice as big as a black tile, which means that for every one of these, there have to be 2 of these guys. So that must mean that there are 2 times as many tiles here as there are tiles here, which means that the total number of tiles in the floor is an even number. So this must be an even grid. So we have our answer, right? Our p times q by p times q grid is even. Easy. Yes. But if you look a little further, things get super weird. So what do we know about even grids? We can split it up into half like this and then into half again. Well, this is where it gets interesting. We know that the total number of tiles in the ceiling has to be exactly half the total number of tiles in the floor. The floor has 4 times however many tiles there are here. So however many tiles there are here is the number of tiles there are here, which is an even number, because you can see very clearly that every tile here can have a unique friend here, and that's what an even number is. So that means that this is also an even grid. And what do you know about even grids? You could cut them into 4 pieces. And now is a very weird thing. We have that this piece is exactly the same area as this piece. It has to be because these two have the same area. So how many tiles are there in here? We know that it is twice the number of tiles that are here, which means that it's an even grid, so it can be split in half into, it can be split into 4 pieces. We know that this has exactly half as many tiles as are here, so this is also an even number, which can be split into 4 pieces. And now we have this same problem again. We know that the number of tiles here is exactly 2 times the number of tiles here, which means that this is an even grid. This is half of this, so it's an even grid as well. And we can keep going forever, as many times as we want. What does this mean? It means, unfortunately, that this tiny square that we imagined was tiling these guys together doesn't actually exist. This was all a lie all along. If it existed, it would have to be this tiny, tiny thing that can be subdivided over and over and over again, and that's not possible, so it doesn't exist. Wait, am I even hearing what I'm saying right now? No! This means that our method of using building block squares won't work after all. Do we need to give up hope that we'll ever find a solution? Maybe there is some other way to get the tiles to line up without using these building block squares. There has to be a solution, and there has to be a way to find it, right? Please tell me there's a solution! Sorry, I've collected myself now. Let's think about this again. Okay, so what we now know is that the black and orange tiles cannot be made up of an even smaller tile that kind of builds both of them. This is different from the situation we had with the red and blue tiles, where this one tile here builds both the red and blue tiles. In the black and orange tile situation, there is no such thing as this kind of small tile. Well, let's try to think about our big question one more time. Let's imagine that this is our square room, and let's just imagine, okay, forget, even if we don't have an obvious way to figure out how many black and orange tiles go in there, but let's just imagine what happens if we do. Let's imagine that this square room is actually tiled by both the black tiles, so we just have Q of them in here, and by the orange tiles, so we have P orange tiles. And I just drew one example. Well, if we are in this kind of situation, I think we actually will need to have a tiny tile that builds both of our black and orange tiles, even though we know that it's impossible for sure. And let me show you why I think this. I'm going to show you how to construct a small square that will end up building both the black tiles and the orange tiles. Let me show you how. It's very easy. Our room can be tiled by Q black tiles and P orange tiles. Then what happens when we split up our room into P times Q slices, just like I did here, is that we've split up our big room into these tiny squares. And my claim is that this tiny square has to build both the black and orange tiles. Since our room can be sliced up into P times Q slices, we could group together each of our tiny squares into groups of P. More specifically, we can group them up into Q groups of P. And so if we treat this new grouping as one big tile, then Q of these tiles, placed end to end, fit perfectly in our room. Guess what else fits perfectly in our room when Q of them are placed end to end? That's right, the black tiles. So that means that the black tiles have the same area as a P by P grid of each of these tiny squares. So we found one square that can build our black tile. It turns out that this same square can also build the orange tiles. Since we divided it into P times Q slices, we could group together the tiles into P groups of Q. So again, let's treat each of these squares as a new tile. Then P of these tiles, placed end to end, fit perfectly in our room. What other tile fits in the room when you place P of them end to end? The orange tile. And so what that means is that these tiny squares are exactly the right size to be able to build back this orange tile. But wait, we just showed before that there's no such thing as a tiny square that can build both of these tiles. And what we just now showed is that if we do get a solution to our problem, trying to find a room that can fit both of these two tiles, then there has to be a small square that tiles both of these guys. What does that mean? This is devastating news. What this means is that it's actually impossible to tile our room with these two squares. If we want to tile a room with these two squares, we have to cut some of the tiles. I hope you can forgive me for leading you astray so much. I knew from the beginning that this was an impossible question, but I hope that the joy of discovering how impossible this is allows you to forgive me. Can I ask you to do a favor for me? Please cherish that feeling of betrayal that you just felt. Getting to experience this strong emotion is why I love math so much. And I want you to know that whoever you are and wherever you are in your life journey, it is very possible for you to keep experiencing this as well. What we have just gone through together with this question about black and orange tiles is one of the most universally adored ideas across all mathematicians. It's a proof that the square root of 2, which is what we call the ratio between the side of a square and its diagonal, is irrational. This feeling of betrayal that you feel is exactly what makes this proof so endearing to so many people across so many different cultures and moments in history. I hope you can feel like this feeling is your own now as well. And if some things are still a little confusing, which is not your fault at all, I made this video very, very fast-paced. Please don't be shy to rewatch parts of this explanation and ask questions in the comments. I hope you had fun. This is something that I really love to show people, and it means a lot to me. And the reason why this means a lot to me is because I see myself and my relationships and my kind of stubbornness being reflected over and over again in this theorem. I feel so often that when I have an issue with an idea that I'm holding on to, or an issue with another person who I want to get along with but I can't, I feel like what I'm searching for so desperately is some ratio between black and orange tiles that will make the tiles line up without having to cut any of them. I feel like I'm driving myself crazy trying to find a ratio that doesn't actually exist. And kind of a little bit deeper than this idea, what I really love about this is that in trying to reflect on this problem, trying to figure out the answer to this question, we are led immediately to a kind of fundamental assumption that we're having. We realize that in order for tiles to line up in the first place, there needs to be a common small tile shared between them. And this gives us so much hope. We finally identified the one thing that we need. I have this experience so many times where I realize what my issue is, what another person's issue is, or whatever. I think I understand it. But when I make the next step and I reflect on other things that I know, other feelings that I've had, I realize that something even more fundamental is in contradiction with this. I kind of go on this journey of like, okay, I have identified all different possibilities. I have simplified down every situation into either even grids or odd grids. And then I try to apply it to the scenario that I'm looking at. And I realize that something is completely off. And if I really want what I'm looking for so desperately, in another person, in myself, whatever, I will have to accept something that I cannot accept. And what this forces me to do is to let go of that one kind of fundamental idea that I held on to so long. There's a kind of silly but bittersweet anecdote I'd like to share about this. I have a friend who means a lot to me, and for a long time we were dedicating so much of our attention to each other. Both of us felt pressure from many different things, and we also gave each other a lot of pressure. And there were many times where we got into arguments, and there were many times where I thought I finally understand what is happening, and that I've identified the kind of fundamental assumption that is necessary for the expectations that I hold on to in our relationship. There was a time we were both in school and it was final time, so we decided to procrastinate. After kind of working on essays and whatever, we decided to eat, and we got talking about math a little bit, and I showed her this problem. This is a problem that I had tried to show her many times before, but I always kind of messed up the way I did it. But this time what I did, I just showed her this question, and she kind of latched onto it. She got obsessed. She went to a blackboard after dinner and tried very hard to solve it. I was kind of happy inside to see this, and a little annoyed because I needed to do homework, but it was exciting to see her working on this. At some point, kind of like when you get a joke, she realized that this problem boils down to the square root of 2 being irrational, and she got super excited, and she realized finally what I had been trying to say to her. She said that she couldn't understand how I was keeping this all to myself, and that I must have felt so lonely. And we hugged, and we were happy that we could feel clever and also appreciate each other in a way that we hadn't been able to in a long time. Eventually we did realize that we had to let go of many other things, and we let go of many expectations that we held for each other. And this process is always very painful. And I experienced this over and over and over again. This memory is one of the strongest memories that I associate with this puzzle. And it makes me very sad, but also very happy to reflect on it. And it really fills me with this conviction that this idea is so beautiful because it's so painful to accept this. It feels like a betrayal to ask a question and have an expectation for an answer and then realize that you asked the wrong question. But even through this pain and shock, there is so much beauty. I want for there to be a solution to this problem, to be able to tile the floor and ceiling so that there's no parts that I have to cut off, because that would make things really nice and convenient for me. But if I accept that it's actually impossible to do this, I need not give up hope of experiencing any beauty, because there are different ways to tile the floor and ceiling. One way is just rotate the floor 45 degrees so that it lines up perfectly at the midpoints of the ceiling tiles, and then just make the room as big as you want it to be. And this pattern is actually so much more beautiful and so much more natural than the one that I was searching for all along. This pattern brings me so much comfort because it reminds me that it is beautiful to let go of what I hold on to so much, that there is so much relief for everyone, and even though it's very painful for me to let go of something that matters a lot to me, I will still feel something beautiful. I will still be comforted by it. So who math is to me is a reminder of how much I want to hold on to things that I believe to be true. And math is always a reminder that I need to have the flexibility to let go of my beliefs. Math is a very playful person. I mean, Just more specifically, I find it so funny that even though these kind of crazier pairs of square grids, even though the red and blue ones can tile a square perfectly, something as simple as these two squares cannot. I also find that math is very patient. I've been thinking about this problem for over a year, 2 years, maybe 3 years, and there were many times where there were like some details that I just didn't fully get, and I continued that kind of misunderstanding for a very long time. I didn't feel any pressure from math itself to get the ideas right the first time. All of my perspective shift happened just because I realized I wasn't understanding math the right way. It reminds me a lot of many very mature people that I know and who I'm friends with, who are perfectly fine with me completely misunderstanding who they are. They kind of wait for me to figure it out for myself. Math feels to me a lot like that kind of person, because any misconception I have about math doesn't change math at all. It doesn't feel sad about it, but any misconception I have actually forces me to change how I think and mature as a person. So this is who math is to me. Math is a very patient and playful friend, and they teach me a lot about myself, and they teach me how to let go. Ah, the weather's so nice. Let's go for a walk together. I also want to tell you about some things that have been on my mind. You're still sniffing that plant? Does it really smell that interesting? I'm glad that you're enjoying it. Anyway, I'm at a very weird time in my life where I've had to say goodbye to many commitments and people. In the past few years, I have said goodbye to my college life. I've said goodbye to a relationship. I said goodbye to future plans. And just a few days ago, I quit a job where I had so many people who I love to work with. So in this chapter, I'm going to share a story of how I dedicated myself to each of these 4 different people and commitments, and why I ultimately chose to give all of them up. I share these stories for 3 reasons. The first reason is that I want to remind myself that the world does not end when I say goodbye. The second reason is I want to show you that these big life changes are very bittersweet, and I hope I could give some kind of inspiration to anyone else who is going through some major changes. The third reason is that I want to express how much comfort I feel when I use this square root of 2 irrationality proof as a metaphor for the emotional turmoil and relief that is always accompanied by my decision to let go of commitments like these. It might sound strange, but the ideas that I talked about in the last chapter have always felt like it was comforting me during these big changes, even while at the same time it was kind of in a tongue-in-cheek way poking fun at me. So I'm going to move through each of these 4 different commitments, one by one, and tell something about it that made me feel very happy, and then explain why I nevertheless decided to let go of it. The first commitment that I gave up was my time in college. I decided to finish college a year early, and maybe some parts of it weren't really completely well thought out, but the overwhelming feeling I had from it was that I was ready to move on and I needed to have different experiences. There was one experience I had at the very end of college which I really, really loved. It was just before the final in my last semester of college, where I was in a geometry class, and after a week of everyone in class giving presentations about different topics, for the last class, my professor decided to treat us with some food from Panera Bread. Different donuts and bagels and sandwiches, and the theme was different. And the theme with the food was different surfaces that had different geometries. But for that last class, we all kind of put the tables together so that we could all sit in a circle and eat together and talk. And I remember we asked the professor a lot of embarrassing personal questions. But I really loved this moment because it reminded me of what I really loved about college. There are many moments like these that I experienced where I could feel the kind of distance between a professor and a student decreasing. And after spending so much time in a very structured environment where I learn from a professor or I kind of work on projects with my classmates, we could kind of let go of all of that and see each other as just people to talk with and eat with. One of the biggest reasons why I felt like I had had enough of college was because I was sick of this arbitrary distance that I felt like I had to put on in front of a professor or in front of other students. There were many times where I wanted to kind of engage with professors on some topic that I found interesting, and when I asked them questions, it was very clear to me that they were just trying to fill the role of a professor, and they didn't really see me as someone they could engage with intellectually. Of course, there were many very good teachers as well, but I realized after putting so much effort into reading or writing or working on whatever, that as long as I was in college, I would be forced to engage in this kind of weird dynamic. That, coupled with some other pressures, I felt like feeling like I wasn't really accomplishing anything and that I needed to get real life experience, made me decide to leave a year early. But I felt very comforted that toward the end of college, I could at least experience again what kept me engaged in college the first place, which was kind of the respect I had for professors and for other people, and a desire to interact with them as people. The second commitment that I let go of was with a relationship that was very important to me, and it actually happened a few months after graduating. I won't talk much about the breakup, but I will talk a little bit about one experience that we had together that I think shows so much of both what made us happy to be with each other and what brought us a lot of pain. A few years ago, my partner and I decided to go hiking in a very beautiful mountain range. So on the day of our trip, we got up at 6 a.m., went to the mountain, and stayed there until like 10 or 11 p.m. So it was an all-day trip, very exhausting, but very fun. The weather that day was kind of a mix of sunny and cloudy. At some points it rained a little bit, but there were many points where we were so high up in the sky that either we were in the clouds or the clouds were below us. And there was actually a very beautiful cliff that we went to where we saw so many clouds beneath us that it felt like we were two ants looking down into a cauldron where there was kind of a steamy broth being boiled. And we went somewhere else and then returned to the same location an hour later. And then all the clouds actually disappeared. And we could see a crazy, dizzying view of mountains beyond mountains. No end to the horizon. I talk about this experience because all day we got to chat while walking and eat together with the food that we prepared. And both of us felt very lighthearted, I think, all day. It was an interesting time, though, because we were both very aware of many pressures that we felt from ourselves and our families and from our life situation, that we were very stressed and oftentimes taking it out on each other. This was about a year before we broke up, but even then we were very aware of our paths diverging, and we were very scared of it. But I think that day together represents so much of our lived emotional experience for several reasons. I think like the time when we got to see the view at the top of the cliff, once like an ant looking into a broth, and another time like ants on top of crazy high mountain. There were many times where we were kind of going back and forth between not being able to see our futures because of the crazy fog and seeing our futures with so much clarity that it kind of scared us a lot. I remember we were both very indecisive about what we were planning to do in our future or even in the next month. And even though it was very scary to be a little ant on top of a broth, there was a little bit of comfort at not knowing what was going to happen. And I remember feeling that kind of comfort at not knowing what was happening over and over again. But I also remember many times in our relationship feeling struck by a very clear view of what is happening, what our attitudes are and what our futures look like. And at those moments I felt very excited at the same time that I felt super scared. It really did feel like I was going to fall and lose myself. And so I remember going back and forth in my emotional state between feeling this kind of weird comfort, even with angst at not knowing what was going to happen in our future, to kind of becoming very clear-eyed and being very scared. But what felt most important to me on that day was not really the cloudiness and the clarity, but the feeling that we had with each other as we walked together. I remember feeling very grateful that she had made me pack so much food in my backpack, because there were so many times where we really did have to eat a lot. And if it wasn't for her, then I wouldn't have brought enough food. And toward the end of the day, it was getting very dark and my partner was very scared. But I remembered that I packed a flashlight in my bag. And so we got to hold a flashlight and go down even though the lights were off. And I remember her feeling very amazed and joyful at this happy situation. By the time we had gone all the way down and arrived at the bus stop where we were going to get picked off, I remember her feeling very jolly. And I was very exhausted, but I was also in a lighthearted mood because of the accomplishment of hiking together and getting back safe. We were both very seriously committed to each other from the start of the relationship to the end of the relationship. And I think that was what made it so hard for us. There were so many practical matters and culture differences that we had to overcome and that we tried to overcome, but which was hard to compromise with. And I think we both derived a lot of comfort from being with each other at the same time that we felt a lot of guilt and maybe repulsion. But I think what was very important to our relationship was that we were both very aware of each other's resourcefulness, even though it wasn't always what we needed. On that day, climbing the mountain range together, I think we both felt very grateful to be in each other's company. Having snacks and flashlight thanks to each other, we had the freedom to relax and be playful. This morning, as I was going on a walk, I saw some geese swimming and drinking and eating on the river. And it reminded me of her. And I realized that for the first time in a long time, it didn't come associated with a pang of sorrow. And today, I guess I also realized that after the decision to break up, even though I'll never be the person I was when I was in front of her, I don't feel lost. And I still feel very calm. Now, the third commitment that I let go of was my hope to apply to grad schools for math. And I was deliberating over grad school for a long time. I even already prepared everything. I wrote a personal statement and asked for recommendation letters. But something like a month ago, I decided to suddenly cancel all of it and give up on applying, at least for now. I am still confused about my decision a little bit, but I think there are two pieces that are very important to it. The first piece was that I realized that the fundamental reason why I wanted to keep learning math in a formal school setting was because I loved having so many playful experiences thinking and talking about math with people and seeing metaphors in math. To give some examples, there have been so many times where I talk with a friend about math, like we share a proof with each other that we really love, and we move back and forth between talking about our like personal life and talking about the details of the proof or whatever it is. And we usually mix this with an activity like walking or eating or something like that. Even though I already graduated, I somehow found a way to take a class at a nearby university, and I met someone in that class with whom I could study. And one time she invited me over to look at a project that we were working on. And I remember after a long time of me trying to follow along with a proof that she was going to present, she realized that she was going to host dinner soon and had to go to the kitchen to chop up some vegetables. But we kept talking about math while doing that, and we even used chopping as a metaphor for an idea in the proof. There was another moment I had not too long ago with a friend I met through work who invited me over to eat together, and we ended up talking about polynomials, as you do. And while we were eating and talking about math and talking about our families and personal lives, kind of felt like all of those were blending together in a very beautiful way. And I realized that I was searching for those kind of very playful experiences more than anything else. I also really wanted, and I still do really want, more formal training in math, and I wanted some kind of math project that I could work on. I wanted to find some proposition I can prove for myself and write a big paper for. But the key thing that I was looking for was those moments, and I think I was going into these applications imagining just those. I realized that if I go into grad school with this expectation, I would be a little disappointed and I would feel a little repressed. I had this realization while talking with my mom and sister, who I've been living apart from for the past few months because I've been working somewhere else. While I was talking with them, I listened to my mom and sister talking about looking into houses and doing chores, and I realized I was so far removed from all of this that I was just concerning myself with things that didn't have anything to do with what my family was concerning themselves with. And I felt some guilt for trying to remove myself from my family in this way. And somehow I think with this realization, it also became clear to me that if I were to go to grad school somewhere very far away from where my family is, I would also end up being very constrained by the many responsibilities I would have. I'd have to, of course, be back in a school environment where there's a very clear distance between a student and a professor, but I'd also have to be making money on my own, which I didn't really feel that I had the energy for, and at the same time kind of be very aware of this guilt I have for distancing myself from my family. And I realized that there's more opportunities to have the kind of playful conversations that I was looking for in grad school if I stayed with my family and I shared with what my family was going through. I'm still not sure what my path forward is, but I think one thing I realized very clearly was that I was kind of trying to force myself into a box by pursuing grad school, and I didn't really want to be in this box, and so I emailed my professors and I said I'm not going to apply anymore, and I'm still trying to figure out what I want. The fourth and final commitment that I recently let go of was quitting my job abruptly after a big event that I had to work. So for over half a year, I've been working at a organization that is supposed to be about math outreach. And going into this job, I thought it would be a very good experience to have some kind of math in my life while still focusing on adult stuff, while still having job responsibilities. And for some time, there were many moments where I got to practice the skills I wanted to practice and develop the experiences that I wanted. There were many times where I got to mentor a lot of people, and there were so many times where I did get to kind of nerd out. And kind of most importantly, I really, really loved the people I got to work with every day. This job very quickly changed to the point where I no longer could do any of the stuff that I actually cared about. And I think I handled it for about 2 months before, after one event that I had to work, I just couldn't take it anymore and I quit. I don't really want to talk about the details of this because it doesn't really matter, but what does matter, I think, is just one example of why I loved my job there and why I also wanted to leave. There was one moment where we were called in to work from morning to like 6 p.m. and then at the last minute, right when we thought our job would be done, we were called to work for some indefinite period of time and just go on a dinner break. I didn't feel very strongly about this at the time, but I was very exhausted and disappointed in this. But I remember my friends and I ate dinner together and we got to complain and also talk about other things. And then before we started work, we asked our manager if we could do some stretches together. The manager agreed. And so we did stretches together before we had to continue with what we were doing. There's kind of like a fun tradition that we have where we put on an exercise video and do stretches together, and getting to do that knowing that we would be stuck at work for a very long period of time after kind of took away a lot of the stress, and it made me feel closer to the friends that I was working with. There were many times where when one of us were stressed, we would reach out to each other, and there were many times where I got to talk and eat together with the people who I worked with. And even till the end, I felt like I was always learning from the people I was seeing every day, and even though I kind of despised the work that I was doing, it was very bearable because of them. So these are just 4 of the biggest commitments that I've had over the past few years, and now I'm stuck in a place where I don't really know what I'm doing. I guess I've never really known what I'm doing. But I hope it's clear that with all of these commitments, I really did love them a lot, and I felt always that I let go of them, not because I fully despised what I was doing, but because what I loved so much about these commitments, the joy that I got from them, was not actually attached to any of the boxes that I was feeling forced to put myself into. With all of these commitments, I felt like I was kind of forcing myself to express a personality that I didn't really want to express, or force myself into a situation that I wasn't very comfortable with. And I realized that all the joy I got from the commitments that I was part of didn't really require me to do that. And what it meant for me to let go of these commitments wasn't so much to say goodbye to the joys, it was more so to let go of the boxes that I was putting myself in, kind of climb out of the boxes, I guess. The square root of 2 irrationality proof that I talked about in the last chapter, to me, represents this feeling that something in my experience is being held back because I'm holding on to an expectation too strongly, or I'm holding on to some belief or whatever too strongly, even though it is harming me. And that to kind of move forward with my life and to gain the insight that I'm so desperately seeking, I need to let go of the things that bring me comfort, even at the same time that they bring me a lot of stress and guilt and angst. This, of course, is more of a me thing than anything kind of like inherent in this one proof that I talk about. Even though I will say that the square root of 2 proof is, I think, a very good choice as a metaphor for my experience. And you could see throughout history, people do rely on this same idea to express similar emotional journeys. But for me, this is where the joy of math comes from, is seeing a very beautiful idea which is beautiful on its own in its abstract universe, and seeing echoes of it in the very kind of terrifying concerns that I have in my everyday life. I really hope that I can keep experiencing this, even if I don't end up studying math in a very formal environment, as I hoped I would. Who knows, maybe I will end up studying more in a formal environment. Anything might happen. But I hope one side effect of me talking about all of this is that you also feel this kind of respect for math ideas that you may not have felt before. And you see how it's possible for me to become obsessed with the ideas I showed in the previous chapter. Okay, thank you for letting me talk. It was very fun to share this with you. In the first chapter of this video, I asked you a very weird question. Who is math to you? And then what I kept doing since I asked that question was comparing myself and my friends to ideas in math, and using that idea as a metaphor. You might be wondering at this point, okay, what does it actually mean to ask this question, who is math to you? And is it okay to keep comparing yourself and your friends to ideas in math? Isn't that a bit weird? This chapter is about those questions. And more generally, it's about a much bigger question. Why should anyone want to do math in the first place? What good does math do for people? Does anything change if we spend a lot of time thinking about math? This chapter is going to be split up into 2 parts. In the first part, I'm going to actually share 3 writers, and secretly it's about 3 different relationships, which were very important to those writers. The goal of this first part is to show you that this idea of asking who is math to you, and this idea of seeking for a friendship through math is not new, and it is actually one way that many people have found fulfillment in thinking about math. My hope with sharing these writers and these 3 relationships is to make it feel less weird that I am talking about math as if they are a person who I can be friends with, and also highlight that behind every major idea, there is a very deep relationship, not just with the idea, but also with other people. In the second part of this chapter, I'm going to make these ideas much more concrete by talking about what it means to ask who is math to you in 3 different contexts, namely a family upbringing context, an education context, and an academia context. In each of those sections, I am speaking directly to parents or caregivers, educators, or researchers. But even if you don't find yourself in any of these categories, I hope that you could still get something out of listening to them and get a more concrete idea of just how much a different relationship with math can change so many parts of your life. The 3 different writers I'm going to talk about are G.H. Hardy, Francis Su, and Simone Weil. And with each of these 3 writers, I'm also going to briefly talk about one person who was very important to them, and how their relationship with that one person was influential to the ideas that they write about. Let's start with G.H. Hardy. G.H. Hardy was an English mathematician, and he was considered one of the leading mathematicians of his time. He's famous, obviously, for math, but also for a lot of essays that he wrote, which were read by a lot of non-mathematicians as well. Among them is an essay called A Mathematician's Apology, and in it, Hardy tries to describe what it means to do math, what math is, and tries to justify his choice of being a mathematician. He wrote it near the end of his life, where it seems like he was feeling very miserable because he was losing a lot of functions that he took for granted throughout his life, and I'm sure since he was a professor, he was always seeing a lot of young people and feeling the contrast between his energy and their energy very strongly. This was also a period of war. This was during World War II, and I'm sure that he felt a lot of guilt and some weird feelings he couldn't really explain because he was a mathematician and he didn't really have anything to do with any war efforts. And you do get a sense of this weird feeling when you read his apology. He tries very hard to say that math is useless. He really doesn't want any association with any of the war efforts. A lot of people recognize this work for putting to words what a lot of mathematicians felt but didn't really say, which was that mathematics is an art form. It's not just a tool, it's not a game, it's something that you can create and put your creative energies toward, the same way that any artist, like a sculptor, painter, musician, can put their creative energies toward composing something or creating something. I think many mathematicians still see themselves as artists, and one of the most common words I hear mathematicians using to describe ideas they really like is beautiful. I bring him up because when I was starting to learn math in college, I was very curious about math being an art form. It felt very weird to me that math could be something like art, because I'd never had an experience like that, where I could do something creative. But when I read Hardy's essay, I was surprised to find that some of the things he says about math being an art are really kind of repulsive to me. Or to put it more kindly, I'm not very inspired by it. And even more weirdly, things that he didn't say about math being art were actually much more inspiring to me. So I'm going to talk about those 2 things. The first is what I felt weird about his idea of math being art, and the second is what I felt much more comforting. So this passage comes from the very end of his essay, and it's kind of a concluding statement of many of the ideas that he was talking about. He tries to describe what use his life had to the world, and he starts to feel a little bit sad. And in this last part, he seems to make a very clear statement. This is what it means for me to be a mathematician. You could pause the video to read the whole thing, but I'm just going to mention this highlighted part. The case for my life then, or for that of anyone else who has been a mathematician in the same sense which I have been one, is this: that I have added something to knowledge and helped others to add more, and that these somethings have a value which differs in degree only, and not in kind, from that of the creations of the great mathematicians or any of the other artists, great or small, who have left some kind of memorial behind them. What felt a little weird to me about this last sentence was that it felt like there was tension between two sides of him. The first side was this part of him that seemed to be very compassionate. He mentions he has added something to knowledge and helped others to add more. It seems like he cares about the well-being of a collective group. The second part of him seems to want to be honored and be appreciated by other people. He says that artists have left some kind of memorial behind them, and it seems to me that he wants that memorial for him as well. There's nothing wrong about wanting to be recognized, and I have that feeling as well, but it felt so weird that these two feelings were put right next to each other. Desire to help other people and also desire to get something fancy for yourself, get prestige. He actually writes a note at the very end of his essay. So right after this quote that I just read, he describes a conversation that he and a friend had where they're kind of arguing over what good being a mathematician is compared to being any other kind of artist. They say that some artists, like writers, kind of leave some of their personality behind with them in the art. But mathematicians, their ideas are very abstracted, and you can't really feel their personality as strongly as you can feel their personality if they wrote something. Another friend, listening to this conversation, chimes in and seems to kind of poke fun at both of them. He says, if I had a statue on a column in London, would I prefer the columns to be so high that the statue was invisible, or low enough for the features to be recognizable? Hardy, hearing this, seems to think it's a very fitting comparison, and he says that he would rather have a column that was so high that they can't see his face, while his friend he was arguing with would rather have a very low column. To me, this really emphasizes Hardy's very conflicting feelings even further. He seems to want to be recognized, and he seems to want to have something fancy attached to his name that people will remember him by. But he also seems embarrassed by his very messy personal side. He doesn't want anyone to see what his face looks like. He wants people to recognize how important he is, but he doesn't want them to get too close to him. Seeing Hardy having these kind of conflicts with himself made me wonder if mathematicians all need to have this kind of conflict. I have heard a lot of people saying things like when they started math, they were just doing it because it was a good way to beat other people. They were just one of the best students in class. Math was a way for them to show that they were better than other people. This is encouraged in school because we get awards and good grades and whatever for being good at math. And it seems like this same feeling of desiring some kind of proof that you are worthy or something has stuck with Hardy up until the point that he's writing this essay. He wants undeniable proof of his ability, but the fact that he doesn't seem to want people to recognize his facial features, see too close to him, makes me feel like the desire to beat other people at math, the desire to be good at math, also comes with a lot of things that you're trying to suppress. You have a lot of messy feelings about yourself that you don't want other people to know. But there's also that other piece of Hardy, where he says, I have added something to knowledge and helped others to add more. And this part actually inspired me a lot more. I see in a different part of the essay, just a few paragraphs before this last part, Hardy describes what it was like for him to grow up into a mathematician. He describes his school and some very important experiences in his life. And one of these he mentions was when he got to work with two other mathematicians who were also leading mathematicians of the time. One of them is named Ramanujan, and the story behind how Hardy and Ramanujan met is really interesting in itself. Ramanujan lived in Tamil Nadu in India, and he mostly self-taught himself a lot of math. He was trying to work with other people who were in the university nearby where he lived, and a lot of them recognized that he was very, very clever, and they wanted to support him to get better experiences, to talk with mathematicians who were able to understand him better. They helped him write a letter to G.H. Hardy because he was one of the leading mathematicians of their time, and Ramanujan sent a very famous letter that detailed his poor circumstances and some of the work that he was working on. Hardy, for some reason, decided that this was someone who was worth working with, and he and some of his friends worked with Ramanujan and his friends to get Ramanujan to come to Cambridge University, where Hardy was working. They became friends and colleagues, and their relationship is celebrated about as much as the ideas that emerged out of their collaboration. This story by itself makes me feel that Hardy does really have this kind of compassionate side to him, and that he does really feel proud for not only adding something to knowledge, but helping others to add something else. What I found very crazy was how Hardy talked about Ramanujan. Hardy says, "I wrote a great deal during the next 10 years after his initiation into math, but very little of any importance. There are not more than 4 or 5 papers which I can still remember with some satisfaction. The real crisis of my career came 10 or 12 years later, in 1911, when I began my long collaboration with Littlewood, another leading mathematician, and in 1913, when I discovered Ramanujan. All my best work since then has been bound up with theirs, and it is obvious that my association with them was the decisive event of my life. I still say to myself when I am depressed, and find myself forced to listen to pompous and tiresome people, well, I have done one thing that you could never have done, and that is to have collaborated with both Littlewood and Ramanujan on something like equal terms. It is to them that I owe an unusually late maturity. I was at my best a little past 40 when I was a professor at Oxford. Since then, I have suffered from that steady deterioration which is a common fate of elderly men, and particularly of elderly mathematicians. A mathematician may still be competent enough at 60, but it is useless to expect him to have original ideas." Toward the end, he gets very sad. But this part that he admits that when he is depressed and he can think of no other justification for himself, he goes back to the thought that he was able to collaborate with Littlewood and Ramanujan on something like equal terms. He felt happy that he could be equals with them. Maybe some of that feeling has to do with the fact that they are kind of also recognized as very good mathematicians, and by being equals with them, he also is a very good mathematician. But I am sure that another big part of this does have to do with the personal connection that he feels toward them. When he says something like equal terms, I think he is talking about the ability to kind of see himself in them. I was curious about Hardy and Ramanujan's relationship, and so I read another paper that he wrote, or it's more like a transcript of a lecture that he gave, where he tries to talk about Ramanujan's legacy. He starts off saying that he's going to try to show what Ramanujan's mathematical legacy should be, and he begins with a lot of also celebrated quotes that to me are telling of both this kind of compassionate side to him and also this more egotistical side of him. He admits that there were difficulties in working with Ramanujan. Ramanujan was an Indian, and I suppose that it is always a little difficult for an Englishman and an Indian to understand one another properly. But very soon after he says that, he says this: "The real difficulty for me is that Ramanujan was, in a way, my discovery. I did not invent him. Like other great men, he invented himself. But I was the first really competent person who had the chance to see some of his work. And I can still remember with satisfaction that I can recognize at once what a treasure I had found. I saw him and talked with him almost every day for several years. And above all, I actually collaborated with him. I owe more to him than to anyone else in the world, with one exception. And my association with him is the one romantic incident in my life. The difficulty for me, then, is not that I do not know enough about him, but that I know and feel too much, that I simply cannot be impartial." A little bit underneath that, he also says this: "The picture I want to present to you is that of a man who had his peculiarities like other distinguished men, but a man in whose society one could take pleasure, with whom one could take tea and discuss politics or mathematicians. The picture, in short, not of a wonder from the East or an inspired idiot or a psychological freak, but of a rational human being who happened to be a great mathematician." I really adore the way that Hardy talks about Ramanujan here, Because while it is still infused with this language that I'm a little turned off by, like him saying, I can still remember with satisfaction that I could recognize at once what a treasure I had found, and him having this apparent fantasy about Ramanujan being like a great man who invented himself, these quotes still, to me, reveal so much care and respect that Hardy had for Ramanujan, and a lot of self-aware maturity on him having a relationship with someone who is from a very different culture. By this kind of maturity, what I mean is that he acknowledges that there were culture differences between them, and he could feel the awkwardness at some points. But at the same time, he's probably been hearing other people talking about Ramanujan, and he feels very weird about them, because to him, Ramanujan is a rational human being who happened to be a great mathematician. He has peculiarities like other very distinguished men, but he was fun to hang out with, and he was just as much of a, sophisticated person as I was. Especially that language of a rational human being who happened to be a great mathematician speaks to me, because their relationship started because of a shared taste in math. But it's clear that as he spent more time with him, he got to appreciate Ramanujan so much that he didn't just see him as a means of doing math together. The fact that Ramanujan was a great mathematician was just a very happy accident that helped their friendship blossom. What I think I'm trying to get across here is that I think Hardy's idea of math being an art form is born out of two very strong but conflicting feelings inside him. One of them is his desire to be recognized by other people, but not too recognized, to have some distance. Another is his happiness with having someone he can share his tastes with. It's his feeling of happiness in having a very good relationship with someone he gets to work together with every day. I feel this compassionate attitude and this egotistical attitude kind of blending together in this idea of math being an art form. And I didn't really say it very clearly to myself this way, but I think having this kind of intuitive feeling that this idea of math being an art form is mixed with these two conflicting feelings kind of pushed me to search for a different way of relating to math, and a different idea of what it could mean to be a mathematician and what it means to do mathematics. So next I'm going to talk about another mathematician whose writings influenced me around this time as well, and who I think started to shape my understanding much more than Hardy of what math is and what it means to be a mathematician. So Francis Su is a professor who teaches at a liberal arts college in the US, and he wrote a book in 2020 called Mathematics for Human Flourishing. This is a book that I really like to recommend to people, partly because I had read a small part of this book for class in college, and that part really did shape my kind of expectations of what math can be, but also because it symbolizes to me a very strong attitude, which to me is much less mixed with conflicting desires like in Hardy's desire to be an artist, and it's more obviously inspiring to me. In this book, Francis Su starts with an anecdote about someone he got to meet, and I don't really want to spoil the details, but he's talking about a person named Christopher Jackson, who had a very different life than many people do. And at one point of his life, when it seems like he would be struggling a lot, he started to gain an interest in learning, and in particular in math. And he sent a letter to Francis Su. It seems like mathematicians rely a lot on letters, by the way, to communicate and start relationships, where he described his situation and desire to learn and asked if there was a way for him to learn from him. This relationship seems to be very influential to both of them. It seems to have been one of the biggest reasons why Francis Su decided to write the book in the first place. And I won't mention any more about it so that you could go read it yourself, but I will briefly talk about a few ideas that Francis Su says in the first chapter of that book that really shapes my idea of what math is and what it means to do math. Around the middle of the first chapter, Francis Su says, "To miss out on mathematics is to live without an opportunity to play with beautiful ideas and see the world in a new light. To grasp mathematical beauty is a unique and sublime experience that everyone should demand. All of us, no matter who you are or where you're from, can cultivate mathematical affection. All of us can have a different relationship to mathematics than we imagined. All of us can read ourselves and one another differently." He clarifies a little later, "Reading ourselves differently will require all of us, those who've failed at math and those who've been successful, to change our view of what mathematics is and who should be learning it. This will require teachers to change their view of how they should be teaching it. We'll need to speak about it in a different way. And if we do, more of us will be drawn to mathematics when we see how mathematics connects to our deepest human desires. So if you ask me why do mathematics, I will say this: mathematics helps people flourish, and mathematics is for human flourishing. A little later he says, I'm saying that the pursuit of math can, if grounded in human desires, build aspects of character and habits of mind that will allow you to live a more fully human life and experience the best of what life has to offer. None of us is wholly virtuous. We all are works in progress with room to grow. And there are many ways to grow in virtue, not just in mathematics. But does the proper practice of mathematics build particular virtues, like the ability to think clearly and to reason well? Unequivocally, yes, and it may do so in a distinctive way. This was introduced to me in one of the first proof-based math classes that I took, and one thing that I was very inspired by here was this idea that we can have a different relationship with mathematics than we imagined, and we can learn to read ourselves and another differently. This idea of seeing something that we are already very familiar with, but trying to see a different perspective, trying to see it in a new light, just made a lot of sense to me. It felt to me from what we were doing in the proof class that fundamentally what we're doing is just looking at something in a different way. We're searching for ways to go from one way of seeing something to another way of seeing something. It made sense to me that math of all things can be a very distinctive way of accomplishing these kind of human virtues that Francis Su seems to talk about. Because at the core of the virtues that Francis Su wants people to recognize mathematics is capable of arousing is this idea of reading something differently, reading something we're familiar with differently, reading ourselves and other people differently. I especially like this call to our teachers to change their view of how they should be teaching it, and especially this idea that the way that we talk about something can have a very big influence. These are ideas that I always was very sensitive to. Maybe a big reason was because my mom always said these things to me. But this idea of growing as a person, living a more fully human life, from learning to see yourself differently, learning to see other people differently, and paying attention to the language that we're using or the inherent attitudes that underlie our language. All this really inspired me to search for something more in math. As I took more math classes, I kept searching for something that would help me see something differently. I kept searching for different ways of seeing the same thing, and I kept trying to connect math ideas with the relationships I had. I think the people who I learned math from were very influential for helping me have this kind of relationship with math. What I'm saying here is that this idea of asking who is math to you, and this idea of comparing math to friendships and comparing myself to ideas in math, stems from a desire to read mathematics, myself, and people in my life differently, and to find a new way of talking about mathematics, just like Francis Su calls for. Even though mathematical objects don't look anything like humans, practicing the art of looking at the same thing in different ways continues to help me learn to be empathetic to real people. And so my hope is that asking the question, who is math to you, helps more people realize that one of the deepest desires they have, the desire to be listened to and to be read differently than the way that others currently read them, is connected with learning mathematics. Francis Su also quoted another writer named Simone Weil, from whom he actually got this idea of reading people and yourself differently. I kind of kept Simone Weil in my head, and actually a little less than a year ago, I found this writer in a bookstore, and I kind of recognized the name. It seemed like an interesting book. I picked it up and decided to read it. And this writer actually helped me understand Francis Su a lot better. And they helped me with this process of putting my feelings to words. I noticed a lot of the ideas that Francis Su was talking about in Simone Weil's writings. But I want to show you a small snippet of their writings that I think captures a lot of the ideas that Francis Su was talking about. And it at least makes it clearer to me what exactly it means to talk about math differently, have a different relationship with math, and also kind of learn to read another person differently. The first of Simone Weil's writings that I want to share are actually from a series of letters that they sent to their older brother when that older brother was in prison for refusing to go to the military. This was also during World War II, So this was kind of contemporary with G.H. Hardy. But it seems like Simone Weil wanted their older brother to have someone to talk with. So they ended up having a lot of nerdy discussions about math, about history of math, philosophy, lots of things like that. Simone Weil's older brother, Andre Weil, was one of the leading mathematicians of his time. An interesting thing about their relationship is that Simone Weil dedicated a lot of time to learning Greek mathematics. It's kind of clear to me that Simone Weil had a very strong sense of the ideas that I talked about in the first chapter. I got a sense that learning geometry was about this idea of learning to see one thing in a different way. Now, Simone's brother, Andre, he was kind of always very good at math. There's kind of an anecdote in his autobiography where he says that when he was growing up, one time he got hurt and Simone Weil wanted to help him but didn't know how. So they went and fetched their algebra book to cheer them up. So here we have a letter between two siblings who were both very influential in their own ways. But in this letter, I find something interesting. Simone Weil makes a very strong comparison between geometry and algebra. This is what is in this letter. I have succeeded in getting the book on Babylonian and Egyptian mathematics. There is one really amusing Babylonian problem. They give the dimensions of a canal to be dug and the daily output of a worker in volume of earth displaced, and the combined total of working days and workers. What has to be discovered is the number of working days and the number of workers. I wonder what our pupils' parents would say if a problem so formulated was set in an exam today. It will be amusing to make the experiment. Strange folk, those Babylonians. Personally, I don't much like their spirit of abstraction. The Sumerians must have been much nicer people. In the first place, it was they who invented all the Mesopotamian myths. And myths are a lot more interesting than algebra. But as for you, you must be a direct descendant of the Babylonians. I myself quite agree with the Pythagorean saying that God is ever a geometer, but not that he does algebra. Anyway, and however that may be, I was glad to find in the last letter I've had from you that you deny belonging to the abstract school. They also say a little later in another letter, "It is for the Greeks that mathematics was really an art. It has the same purpose as their art, to reveal palpably a kinship between the human mind and the universe, so that the world is seen as the city of all rational beings. And it did really possess a concrete subject matter which existed, like that of every other art without exception, in the physical sense of the word. This subject matter was space. That is, the actual datum of space, to which all human actions are subjected as a material condition. I fear that our tendency today is rather towards the Babylonian conception, towards mathematics as a game more than as an art. I wonder how many mathematicians today regard mathematics as a method for purifying the soul and imitating God. Then again, it seems to me to lack a concrete subject matter. There is a great deal of axiomatic work which makes an apparent resemblance to Greek methods, but is not the choice of the axioms to a great extent arbitrary? You speak of concrete material, but does this material essentially consist of anything except the sum total of mathematical work achieved up until now? In that case, present mathematics would be a screen between math and the universe, and therefore between man and God, conceived in the Greek matter, instead of a contact between them. But perhaps I calumniate it. What I see here is partly very funny banter between two siblings, and partly Simone Weil's sensitivity to the attitudes that underlie any activity, in particular mathematics. I really like that Simone Weil playfully compares Andre to Babylonians, kind of poking fun at him, even though he's been a prodigy all his life. He's nothing like the kind of real mathematicians, the Pythagoreans. But what I mean about the attitude that underlies mathematics is Simone Weil's efforts to contrast Greek geometry with Babylonian algebra. It seems like Greek geometry for Simone Weil represents efforts to really grow as a person. This is described as kind of a kinship between the human mind and the universe, and kind of a connection with God. But I think another way to put this is a serious kind of self-reflective attempt at becoming a better person, at becoming humble. I especially find it interesting that Simone Weil attributes this attitude to one piece of Greek mathematics, which is that it possesses a concrete subject matter, namely the space that people live in. The importance of it being concrete is that only when something is concrete does it make sense to talk about seeing it differently. Seeing that a square grid of square tiles has to have either an even or odd number of tiles in total feels satisfying to us, because we see square grids all the time, and it's easy to not even notice them. But the next time you look down and see that you're on a square grid, you can choose to ask yourself if it has an even or odd number of tiles. You can choose to see it differently, rather than just not even notice it like you usually do. Meanwhile, if we say that if n is an even integer and squared is even, and if n is an odd integer and squared is odd, it doesn't feel as satisfying, even though this statement is logically equivalent. What I think Simone Weil is saying here is that to feel moved by a perspective shift, we need a subject matter who is concrete to us. And that's, I think, at the core of their argument that Greek geometry is able to help us kind of mature as people, have a closer connection to God, than Babylonian algebra. The key isn't on the subject matter itself, but about the ability for us to feel moved by the perspective shift, the meaningfulness of there being a perspective shift in the first place. Now, returning to the letter, in contrast to what Simone Weil sees Greek mathematics to be, they say that Babylonian algebra is treating math more like a game. It's especially clear with this example that they brought up, where you have all this information and you're trying to find this other piece of information. There's nothing wrong about having some information and trying to find another piece of information. What's silly is about this problem. It tells you the combined total of working days and workers. You're combining a number that represents time and a number that represents people. It doesn't make sense to add the number of people and the number of days together. In no situation is this ever going to be something anyone cares about. It seems to me that Simone Weil tried to connect with other mathematicians. Since they spent a lot of time with their brother, I'm sure they had lots of connections with other mathematicians. But they always felt a little disappointed by the feeling that what they were pursuing for were answers to open questions. And a lot of the ideas they talk about had to do with how difficult a question was, rather than what it reveals about perception or what meaning it has in your life. I think this is really the kind of contrast that I also felt between seeing Francis Su's writings and seeing G.H. Hardy's writings. If you read the whole of G.H. Hardy's Apology, you will get some sense that is closer to what Simone Weil is talking about there, especially when he brings up like the square root of 2 irrationality proof and the proof that there are infinitely many primes. It seems to me that he's alluding to this kind of universally felt awe at ideas kind of harmonizing and ideas being connected with everything. Especially one of the ideas that he says in that essay is that real serious mathematics should try to connect many different ideas together. And this really does sound like what Simone Weil is saying, which is you're getting to perceive something in a new way. So Hardy definitely does have this real artistic side of him. But when he was talking about wanting to have a memorial after him or wishing that he could have some kind of reputation, it feels to me that at those moments he's treating math more like a game, something that has like a clear hierarchy of who is a good mathematician, who is a bad mathematician. And it doesn't really matter what perspective shifts the individual went through. What matters is about getting your name on the leaderboard. And it's because he loses sight of the concrete subject matter of space or, well, in his case, it was prime numbers, I think. This act of losing the concrete subject matter is behind this more game-like perception of mathematics. Now, I don't really fully agree with Simone Weil's point here that algebra and geometry can be kind of divided this way and that algebra has Babylonian origins, Greek geometry has Greek origins or whatever. Because there is a lot of algebra that I really, really like and which I think really does get to the core of a lot of perspective shifts. It has kind of the same spirit that Simone Weil is talking about. But I think there still is a real worthwhile distinction here, where one attitude of mathematics is to improve as a person and in particular learn to see something in a new way. Another attitude is more about developing your skills and being better at something than other people. I think both sides are very important. It's very good to have this game-like perspective as well. It's good to kind of develop your skills this way. But if a lot of people don't recognize the core of mathematics, like it seems like Hardy was able to get confused about, then it's very easy to lose track of what you're doing and fall into a lot of the depressive spirals that it seems like Hardy was also falling into. There's also a few more passages from Simone Weil's writings that I want to share. because I think this will make clear just how powerful math can be, at least for Simone Weil and anyone who has the same attitude as them. This is from the book that I picked up in a bookstore, which was my introduction to Simone Weil, where in general Simone Weil is trying to find a way to make everyone satisfied with their lives. They're thinking about a lot of workers who are forced to do menial tasks all the time, and it's very hard to have a life outside of this. And of course, in the backdrop of this is that terrible war. Simone Weil was French. France was invaded by Germany. The whole Weil family fled to America, and they lived in New York City for some time. It was around this time that Simone Weil was writing this book called The Need for Roots. And throughout the book, I can feel the stakes of what they're talking about. I will also say that I was reading this while working, and so much of it resonated with me because I read some of it before, like on the subway to work, and then I have a terrible time at work. So here are the passages. More specifically, these passages are about how math and other truths like philosophy or whatever can really make a very big difference to people who are working and people who are looking for fulfillment in their lives. Here's the first passage. If a worker in a year of dedicated effort and perseverance learns some geometry theorems, as much truth will have entered his soul as into that of a student who in the same amount of time has devoted equal energy to higher mathematics. And a little bit later, they write, the art of transposing truths is one of the most essential and least known. What makes it difficult is that in order to practice it, it is necessary to place oneself at the center of a truth, and to have possessed it in its nakedness, behind the particular form in which it happens to be expressed. These quotes together kind of start to hint at what mathematics means for Simone Weil. The idea of truth entering into the soul of a worker or a student. I understand that to refer to how much meaning these ideas have. While I read these sentences, I was thinking about the square root of 2 irrationality proof. I thought about that for a very long time, and I have been moved so strongly by the square root of 2 irrationality proof. And part of my efforts of translating a proof that is usually expressed with variables p over q and so on into a question about tiling squares was this strong desire to express how moving this idea can be. When I read this sentence, I immediately had a sense of what the art of transposing truths is. And I felt so relieved that there was someone else who felt these feelings before. It was kind of hard to not feel really discouraged and feel really stupid for spending so much time on a theorem that is able to be understood very easily. Especially since I was trying to share this with other people and I was doing a bad job of it. I felt like I was wasting my time and everyone else's time by trying so hard to get at the bottom of this one idea. No one benefits from it. It doesn't create anything new. But even while I had these feelings, I also had a very strong sense that I was getting something out of it. I was connecting more and more of my life, more and more moments where I had to let go, with the idea of incommensurability. I felt like my inner world was really benefiting from this. And it really did make me both want to learn more math and also take my own life outside of mathematics much more seriously. Because I've personally experienced this, I have an intuitive idea of what Simone Weil is talking about here, and I could feel the power that learning geometry theorems and transposing truths can have. I've done both of these. But I think Simone Weil also puts this insight so undeniably clearly in this next passage I'm going to read. The task of the community school is to confer more dignity on work by infusing it with thinking, and not to make the worker a compartmentalized thing that sometimes works and sometimes thinks. A happy young woman, pregnant for the first time, who is sewing a layette, is thinking about sewing correctly. But she does not forget for one moment the child she is carrying inside her. At the same time, somewhere in a prison workshop, a woman inmate is sewing, also thinking about sewing correctly, because she is afraid of being punished. Both women are doing the same work at the same time, and they are concentrating on the same technical difficulty. Nevertheless, there is a gulf of difference between one task and the other. The entire social problem consists of shifting workers from one of these two conditions to the other. This passage really spoke to me because I was also experiencing this feeling of becoming a compartmentalized thing that sometimes works and sometimes stinks at my work. There were many times where I felt like I was forced to give up any kind of thought at all, to suppress my personality completely, because if I did not, I would go crazy. More specifically, in my last job, I had to do a lot of manual labor. I had to put things in boxes and move them around. There were many times while working where I was moving boxes while having a conversation with my colleagues, and I felt that my time was being worth spent. I felt that I was thinking. I felt like I was putting all of my attention to that moment. I also felt like the outcome of my work, my labor, would be positive. I could see there was a very clear purpose to what I was doing. And I guess I liked the actual physical feeling of moving things. I felt like the pregnant woman sewing a layette. She had something to look forward to, the child in her belly. I also had something to look forward to. There were also many, many moments where I was moving boxes, doing the same thing, and I felt so miserable, partly because I knew that what I was doing came from really bad management, and there wouldn't really be an outcome to my labor. I could tell that I was basically killing time. I was doing it alone, or I was doing it in such a bad mood that I felt guilty for being next to my colleagues, and I felt like I had no choice but to do what I was doing. I felt like I was the woman in prison who was sewing. I recognize these feelings in a lot of people, and I really agree with Simone Weil that maybe one of the biggest things that any real social work is aiming toward is making people find meaning and satisfaction in the tasks that they're doing. And Simone Weil writes about this in more detail in that book. But one way to make this work meaningful for people is to connect everything you're doing with a big picture idea. Connecting it with ideas in math, like through silly metaphors like the one I did in chapter 1, or with philosophy or whatever other kind of big picture goals, things that are clearly about your personal development. I can feel that work will be much more meaningful when I'm thinking about how this is connected to the kind of visions I have for myself. I feel happier doing work when I know what is behind it, and that I connect it with a lot of the philosophy and literature I read and a lot of the math ideas I learn. I know that everyone is capable of experiencing this, and I feel so sad when I see people who are working and they feel like the woman in prison. And I think this is really what is at the heart of Simone Weil and Francis Su's hope for mathematics for human flourishing. The hope of learning to see yourself and other people differently, learning to become empathetic by studying math and other truths or whatever, is so that you can have a better relationship with yourself and with the tasks that you have to do in your life. The reason why anyone might want to study math in the first place is because it changes how you see yourself, how you see other people, how you see the world. And it makes you always thinking, and it makes you always aware of the goal that you have. Math has the potential to make it so that nothing in our life is time-killing, and it really brings more power to ourselves. So to kind of fully respond to the questions I brought up at the beginning of this part, what it means to ask who is math to you is to seek to learn to read yourself differently, seek to learn to just perceive things differently, so that you can have a stronger connection to everything that you do in your life, so that you can find meaning in the work that you are doing. What it means to ask who is math to you is partly to have this attitude of seeking fulfillment in everything you're doing, but it's also an effort to put your feeling to words. It's partly an effort of learning to transpose truths. The benefit of putting your feelings and experiences to words is that you can inspire other people. It could just be people who you talk with on a one-on-one basis. Just a simple conversation you have can change how they see themselves and help them find meaning in their work. So many friends of mine have helped do this to me, just from one-off conversations that they've had with me. And even if they're not aware of it, it has changed me so much. So I hope you could see that the goal of doing math doesn't have to be to go to a better college or go get a better job. And it doesn't even have to be to become an artist and get widely recognized by other people. It can be entirely about yourself and the ideas that you love and the people whom you love. now I'm going to try to show more specifically how this vision can change family upbringing, education, and academia. And the way I'm going to do this is, when I talk about each of these three contexts, I'm going to first present a problem that is very important in each of these contexts. And then I'm going to describe how this attitude that Simone Weil, Francis Su, and I are kind of all sharing in our own languages can help to address these problems in a kind of very clearly transformative way. But please do keep in mind that this is from the perspective of a student. I am not a parent. I haven't been a real teacher, and I clearly have not found a job in academia. I haven't even gone to grad school. So I am aware that I'm talking about something that I have been an outsider to. But I have been an outsider in a weird way, because I've engaged with all of these contexts from the perspective of a young student. And if for no other reason than to be something to think about for people who are much more settled in these contexts, I'll try to share some of my vision for how these three different contexts could look a little bit different than what it is. So let's start with family upbringing. In my most recent job, I happened to work a lot with families, many of them young, some of them older, and I got a lot of questions from well-meaning parents that were something to the effect of these two questions. The first question is, how can I support my kid who is interested in math when I don't know anything about it? And the second question is, how can I get my kid to want to do math when they aren't interested in it? I'll share some of my thoughts on both of these questions. So for the first question, if your kid is interested in math and you don't really know anything about it, that is really good, and I'm happy for your kid. The thing that's most accessible for you to do immediately to support them is to search for online resources that will support both of you. For me personally, my mom introduced me to Khan Academy when I was around 11. Khan Academy is like a free program that has lots of courses on subjects in math and subjects in a lot of things. For me, the programming courses were really influential. I got kind of hooked on learning to program video games. And another source that was influential for me personally was Desmos, the graphing calculator, which I kind of got hooked on when I was 13 or so. The way that I played with this was by trying to draw pictures using the graphing calculator. Now, these two helped me personally, but your case will definitely look different. For that, I would actually recommend using ChatGPT to help you brainstorm and search for online resources. Here is just one prompt that you could send it. If you fill out the blanks with the information that is relevant, then I think there's a good chance that ChatGPT will give you resources that are more tailored to you. Now, if you want to support your kid who's interested in math, and you have a little bit of time and energy to put effort into this, one thing you could do is to try to find one very specific thing that they're interested in and learn about it from your kid. Like, for example, maybe they're obsessed with polyhedra. You can get started with learning about what the platonic solids are. To help you, maybe you could ask your kid to explain just one idea until you have no more confusions about it. This serves kind of a dual purpose. One is that it will make your kid feel good because they will appreciate getting a chance to talk with someone about their interests. And two, it also helps them practice communicating these ideas with other people. Now, if you have a little less time or energy to dedicate to this, there's a few other things you could do. Another is to find support groups or other people who might have similar interests. This still involves a lot of energy to actually find people and maybe set up playdates. But it's a little less involved in the sense that once you do find another person who your kid matches with, you don't really have to put any more effort beyond that. They will kind of take the relationship in their own hands. I have a feeling that Hardy and Ramanujan, the great mathematicians, were kind of like two kids getting to have a playdate with each other. The process of getting them to meet each other in the first place involved a lot of luck and support from their family and friends to set up the meeting, especially since it was intercontinental. But I hope seeing their collaboration makes it seem very possible for this kind of thing to happen. One more thing I'll mention about this question is that I'm very glad that you are supportive of your kid, even when this is something that is a bit foreign to you. If you'd like for math or anything related to feel a little bit less foreign, I really recommend reading Francis Su's Mathematics for Human Flourishing. It is very easy to read, and it has a lot of very touching anecdotes, and it has a lot of puzzles that you can choose to do or choose to ignore, which will hopefully give you a taste of the joy of doing math. I think if you are really curious about what your kid sees in math, this book can help bridge the gap between you. Now for the other question. What if my kid doesn't like math or anything for that matter, but I know that it's important for them to know it, and I want them to find interest in it? I think the best way to encourage an interest in math is for you personally to develop an interest in it. Your kid will observe the benefits that you get. If you get into a habit of learning a little bit of math, it doesn't have to be anything too crazy, and they see the benefits that you get from putting effort into this, then they will on their own decide to pursue math. I think your kid choosing on their own to pursue math is very important. I know personally because I've tried to get other people interested in the ideas that I'm interested in, but if they don't care about it, then no matter what I say, it's not going to change them. In fact, it'll just make things a lot worse. I've learned this the hard way. Luckily, math is a very diverse subject. There's a lot of different ideas that can resonate with lots of different people, and the hard part is trying to find which ideas resonate with you. For me personally, some obvious connections I see between some of the math ideas I like and some of the other hobbies I have is that a lot of video editing and photo editing makes use of a lot of linear algebra ideas. So learning linear algebra felt like I was getting to get a better understanding of the things that I was always playing with. For people who like art, like me, an area of math called projective geometry was kind of developed because people were interested in perspective art and sight. I actually took a class in projective geometry applied to perspective art. And I think the first serious moment of joy I felt from doing math came from that class. And finally, there's an area of math that I kind of learned about recently called knot theory. And the fun thing about knot theory for me was that soon after I learned it, I started to get an interest in braiding hair. And I have an interest in learning how to knit and crochet now because my sister does it and I have friends who do it. But for me, this area of math made me more interested in other hobbies that people have. Now, these are just 3 examples that I could think of off the top of my head, but I'm sure that even if none of these speak to you, there is something that speaks to you. And again, you can use ChatGPT to help you find something that pulls on you. Now, if you already have a deep relationship with math, but your kid does not, and for some reason they're not interested in math even though you are, I think both of you can benefit a lot from you asking them to teach you something that they are interested in. I've done this with a lot of people. I've asked people to teach me something that they are interested in, and if nothing else comes from it, it's fun to do that. And I feel some connection with them. But every now and then there are some very tangible benefits, and in particular there are ways that we can connect this to math again. Just one example, I mentioned that I started to get interested in braiding hair. I had a friend teaching me how to braid my hair. And that led to me talking with them about braid groups, which is an idea in knot theory. And I have another friend who was showing me a cartoon show, and an idea in the cartoon show actually ended up being a very fun metaphor for me to help me understand a different idea in math. So I think there's a lot of benefits that go both ways. Learning from another person opens up opportunities to just talk about math in a casual setting, if you like it already. And it can also change the way that you think about the math that you already know. Now I'm going to move on to math in an education setting. I think in education especially, people are very aware that there are problems with math education, but it's very hard to pinpoint one thing that can change about it. In particular, kind of the biggest question in math education, as I understand it, is how can we get students to see that math is connected to everything in their lives and see it less as a means to a grade? I have 2 kind of ideas on this. One is a lot more low stakes and easier to implement for teachers, and it's about building habits of talking about math differently to inspire your students. The other involves some kind of experiments that I personally would like to try if I ever become a teacher. So for the first one, I think there's a lot of small things that you could do as a teacher that will change the kind of feeling that your students have about math. One of them is to share a lot of personal anecdotes about the ideas that you talk about in class. For instance, if I was going to teach about irrational numbers, I would probably use the puzzle in chapter 1 and then after that share the personal meaning that all of those ideas have to me. This is a little bit unfair because I've had like several years to think about this particular example, but I'm sure that in many of the class ideas that you have to talk about, you can think about some association that you have. Maybe there's like a friend that an idea reminds you of, or you remember when you were a kid, you had this confusion about this idea. Something very simple and low stakes, I think, can help your students realize that they're not alone in wanting to have some connection to these ideas. The kind of big benefit benefit of making a habit of connecting class ideas with personal anecdotes is that there are very concrete examples for your students to think about, where a human being can have a very personal association with an idea that is very abstract. If you would like more examples of this kind of thing, I recommend that you search for the Math Association of America's blog, Math Values. And in particular, there's a collection of blogs called Living Proof, where it shares stories from a lot of mathematicians talking about struggles that they went through in math. I think reading a lot of those stories will help inspire you, and maybe you might even want to share those stories with your students. And if you'd like some prompts to help you get started with brainstorming, here are some prompts that I wrote down. You could try to respond to them, and if they aren't working for you, then just look for better prompts. Another thing that I think can be very helpful is using a little bit of time before class starts to share stories of people you met in your education journey. That's what one of my professors did. She showed the class a lot of people who she got to meet throughout her math journey. She said like a little bit of how they met, what that person is doing, and what that person is like. And that really helped me develop an association between math and friendship. Another of my professors also talked a lot about previous students and how they are using the ideas that they learned in class for their job. She is also very active in kind of seeking to sustain connections, so she even invited some of her past students to talk with us over Zoom. So I think something like that, if you do have some connection with people and they're okay with you sharing, that can also be very beneficial to helping people see that there is something concrete that you can do with these ideas. I'll also say one more thing about this. If you live in the US, there's a chance that you live near a math circle. This is something I heard about from one of my professors, which is, I think, an organization for gathering educators and students together to work on puzzles and have conversations. So if you want to build more associations between math and friendship, or you want to talk with other people, you might want to seek this out. I really hope that these don't feel that crazy to you. These things do require a little bit of preparation before class to make sure you know what to talk about, and maybe you'll have to reflect on your relationship with some ideas. But I hope it sounds very easy to just do every now and then. Because the real benefit of building these habits is that you will give your students more options for relating to math ideas. A single anecdote might inspire a student to learn more, or it might turn into a question that a student will spend weeks or months or years pondering. Of course, not all of your anecdotes have to be successful in this way, and even if none of your anecdotes land on even a single student, this habit still has a benefit, because you implicitly communicate to your students that you respect their autonomy and desire to relate to math in their own way, and they don't have to do math the way that it's done in class to still have a good relationship with it. At least that's the sense that I got when my professors did this. Now, I also want to talk about some experiments that you can do. These are going to be more involved, a lot more preparation, but this is what I imagine I would try to do if I was a teacher. And it's kind of my attempt at seeing how math, even in a structured classroom setting, can still start to develop a new meaning for everyone. So the main goal of these experiments are to encourage self-reflection in students and connect math with some kind of community service. I think these two pieces help people become very conscious of what math means to them and who they are. And it also, I think, makes the connection with empathy much more explicit. So regarding self-reflection, there's a few things you could do. One is to make use of non-standard textbooks every now and then. The idea is to kind of change the way that these ideas are structured. For some teachers, it's easier to do this than other teachers. But one example is to teach calculus in the historical order instead of in the kind of standardized College Board order that it is in now. This is what I talked about in my History of Calculus video, and David Brusud has a very good book that makes it feel like it's a lot more possible to teach a class in a different order. And I think he's very convincing in showing how this order of ideas makes it easier to see a narrative of how ideas like infinitely small go through a period of maturity that spans thousands of years. Now, this is just one example I know, but of course you can use ChatGPT to find a textbook that works for you. But I think more importantly than any textbook that you use is the habit of getting your students to reflect on how they respond to these ideas. I anticipate that for any new thing that you try, some students will really, really like it, and some students will really, really not like it. And I personally have been on both sides of that. When I really, really like a class, I naturally just think, why have I not seen this before? Why did it take me so long to see this? This is so amazing. And I start to wonder what made it possible for me to be blind to this the whole time, and how more people can start to see this. Now, when I was in a class where I was very bored or I was frustrated by it, I thought a lot about why I'm so annoyed by this class and what changes to this class would make me feel better about it. I think there is value in lingering with these kinds of questions. Because as I see it, the most important goal with trying any non-traditional curriculum is to encourage both you and your students to engage in joint self-reflection during the process. You can encourage this by regularly sharing your own feelings in class about what worked for you and what didn't. I had professors who did that. Maybe like one section of the textbook helped you see something different, but another just confused you more. Being open about your interaction with the textbook and sharing your own feelings about what is working and what isn't working communicates to your students that it is okay for them to have ups and downs in their engagement with the course, and that you value being aware of what works and what doesn't work. The most discouraging thing I felt as a student was when I tried to bring up my feelings about what worked and what didn't work in class, and then my teacher said that this course is how they've done things and they aren't going to change it. Things like this, more than anything, made me feel like the coursework was all arbitrary anyway, and it wasn't worth my time to do the work. On the contrary, when my teachers encouraged me to share what I felt, by themselves being open to not being sure if some parts of their course were working or not, it made me care about the class more. Because I felt that my teacher will try to listen to me, and that the reflections I share will be received in the right spirit, whatever they do with it. So I think if you do decide to use a non-standard curriculum or whatever, being very open about not knowing everything is very important and will help everyone enjoy the curriculum much more. Now, another idea I have for self-reflection inspiring things are to try a lot of different one-off activities in your classes. You could dedicate like one class period to trying something new, like trying a bunch of different puzzles, or making a lesson about the history of one idea, or having a kind of literary discussion instead of a math discussion. Like, I don't know, you could assign the first chapter of Mathematics for Human Flourishing to your students and talk about it. These are some resources that I'm personally am hoping to use if I ever become a teacher. And so you might also find it interesting to look through them. I'll also say that I'm not sponsored by anyone. I'm just referencing resources that I think could be helpful. Now, I think there's also some experiments that you could try to help encourage a culture of community service. And the most obvious thing I can think of is to encourage students to teach each other in some way. This could happen by literally setting aside time for students to meet together and help each other on homework. That's what one of my professors did. But another thing you could do is to make use of group projects in math classes. Hands down, the strongest memories I have of my time in college in math settings are the group projects I did. I had so much fun with them, and the ones that I had the most fun with, and which I learned the most from, were the ones where I got to choose who to work with, where I got to choose what to work on, and the ones where I had to do a lot of work in progress check-ins. I was being kind of regularly checked in on to make sure that I was making progress. Now, the last thing that I could think of doing is to regularly announce and encourage like other school activities in class, and make an effort to attend them yourself as well. I had a few professors who did this, where they kind of talk about shared events, even if they weren't necessarily connected with the actual class. And this helped me feel like these many different classes were actually part of one cohesive community. The reason why these kinds of actions are important is because the feeling of community is what your students will remember when they have forgotten everything else. If on the off chance one of your students stumbles across one of the ideas you taught, maybe because they find that they need it for their work or whatever, they will remember that it was connected to you and your community. And they will relearn the idea filled with a sense of nostalgia and curiosity, because they will see the act of relearning to be a way of reconnecting with a small piece of their forgotten past. This is one of the biggest reasons why we need teachers now more than ever, even though anyone can teach themselves anything they want using online resources and tools like ChatGPT. You have the power to help students connect their relationship to intellectual culture with living humans who have ups and downs, and with a particular time in their life that they can come to appreciate again in their future. So these are just some of the ideas I have, and I feel a little bit silly to be giving teachers advice, but I think some teachers would benefit from having a student's perspective of what works for them. So I hope you take it in this spirit. Because for me, all the ideas I talked about now helped connect math with the people I knew, and it became more and more absurd for me to think of math as a means to a grade or something else like that the more I got these kind of experiences. So if it works for me, maybe it will work for some other people, maybe it won't. But I hope the kind of big picture goal of trying to help students develop a connection between math and people, or math and empathy, sounds like a worthwhile thing to put effort into. Now, finally, I'm going to talk about the academia setting. And in particular, what I have felt just from having conversations with people and seeing things from a distance is that there is a bit of a culture problem in academia. Namely, I've seen some people who feel very comfortable in an academia setting and some people who feel very discouraged in an academia setting. And there's no really like social strata which can neatly divide these. It seems mostly independent of those kind of things, and more to do with something a little bit more elusive. I personally have felt very awkward about academia. I felt that in some ways I fit in, and in some ways I don't. And part of my goal with this final section is to describe why I feel this way. So I think one problem that academia faces is this question. How can academia communities be truly committed to an ideal of enabling communication across all people who love learning, not just the people who feel comfortable in academia? At this moment in my life, even though I mentioned that I gave up on grad school applications for this session, I still want to do a math PhD. I don't know when I will get the chance to do it, but I still have it in my mind to apply again. I think my difficulty with this decision has been hard because of two very important things. One is my feeling of comfort about the shared language in academia. And another is my feeling that my fantasy for myself might not match what I see in academia. I'll describe what I mean by both of these in more detail. By shared language, what I'm referring to is kind of the common metaphors and the underlying attitudes that seem to be expressed in how mathematicians talk about math. Very often I hear mathematicians describe math theorems as being like machinery and definitions as being gadgets. I see this very straightforward as a way of comparing math ideas to machinery. And on some level, I can understand why this is a helpful metaphor. There are a lot of similarities between like mechanical things and mathematics. In math, you see a lot of big and small theorems working together to form a unified whole. In mechanics, you see a lot of small and big parts working together to form a unified whole. If you're working in mathematics, you're usually working in just one system or some collection of systems within the big whole. Same with in mechanics, you're working in one system. And I like to imagine that there's kind of a feeling of camaraderie between mathematicians and mechanists, or anyone else who does some kind of like highly technical, maybe physical work, because they recognize the similarities among their jobs. But part of what feels weird to me about this metaphor is that it's very hard to describe math as a relationship when math is supposed to be a machine. A lot of the joy I get from doing math is finding very silly metaphors between math ideas and things that show up in my life. If math is just machinery, it feels weird to pick apart one system and say, this is like my friend, or this is what I'm like. It just feels weird to compare people to machines. And so I think this is maybe some of the weirdness I feel about this language. It's incompatible with the way that I relate to math. Another piece of academia language that feels weird to me is this emphasis on judging the value of something based on how interesting it is. The impression I get when I hear people say the word interesting is that they're kind of searching for something to like hold on to and see if it's worth their spending time on thinking about. I feel that it's very common to hear the words interesting and trivial used a lot. And it, of course, makes sense because interesting questions really are the ones that stimulate the most discussion. And it does make sense to say that some ideas are trivial because it's just shorthand for saying there's not really much more that we can think about here. But I feel that this language goes a little bit beyond a simple symbol of what is worth spending time on or what is not. And it kind of has this underlying attitude of there is a need to progress in mathematics, and that what's worth spending time on is something that will progress in some goal, even if it's some very minuscule incremental progress that you can make. This attitude is what discourages me the most, because a lot of the joy I get in math is ruminating over one idea for a long time. Even after I've already understood a proof, I'd like to try to pick it apart even more and see what other ways I could have expressed this proof. That's what I did with the square root of 2 proof. I feel worried that if I really commit myself to a academia setting, then I will have to give this up, and I'll have to spend all of my time just picking up as many tools as I can and blindly applying theorems that I don't really have a relationship with. For me, what brings me joy in learning math in the first place is spending way too much time thinking about one idea in many perspectives that I know won't really get me anywhere, but I still want to try them. And I also have respect for creating new maths. I have respect for solving open problems and developing new theory. But my vision for myself is that I pursue ideas that have long been trodden, and kind of as a happy accidental consequence of that, I maybe make a little bit of incremental progress or whatever it is people care about. I don't want a pursuit of incremental progress to kind of push me along. I just want to have the freedom to do silly things like finding metaphors between math ideas and my life, and also ruminate over long established ideas, even without any expectation of finding anything new in it. This is really what brings me joy in math. And if I can't do that, I feel like I will become very discouraged, and I think I will lose my love of math. Now, what I mean by fantasy in my life is that I have a lot of people who I want to be like, and they are not necessarily like a research mathematician. I'll just share like 3 kind of simple examples. There's a lot of writers that I like to read, and I'm also curious about their personal lives. And sometimes there is a writer who I am very inspired by, and I want to become a little bit more like in some way. One example is Eddie Halizem. I've been reading her diary very slowly for a while now, and it seems to me that her inner life is just so bright no matter what happens to her. And more specifically, it's very clear she's a messy and flawed human, but she doesn't feel any like strong, overwhelming guilt from it. It doesn't seem like there's some kind of anxious need to suppress herself. It seems like she's trying to still be bright about herself no matter what. And I think it's possible for her to do this because she cares so much about looking deep into herself and also looking deep into her relationships. She doesn't seem to care too much about engaging in big picture conversations. Like trying to solve an intellectual question doesn't matter that much. She's very, very clever, but she puts that cleverness toward understanding the very concrete things in her life. I also have a friend who I want to be a bit like. The person who used to be my partner is someone I still want to be like. A big reason why is that she listens to people and also recognizes in their stories how the things like the economy and politics has influenced their decision making. And she seems to want to know how big picture trends like the economy or politics influences the decisions that people make. This is something that I want to be a little bit more like, because it took me a very long time to accept that this is a very important part of life, and I worry that being in an academia context will kind of encourage me to stay away from these less pure ideas. And lastly, there are a lot of friends I have and a lot of people who I look up to who have learned a lot from doing service jobs, like cleaning or retail or food service or caring for their family. I get a sense that doing something with their body and learning to kind of transform the natural boredom and sometimes hopelessness of being stuck in this kind of job or position has so much meaning. And I don't really want to grow out of touch with that. I want to have some kind of connection with this kind of wisdom. And I feel once again that an academia setting kind of distances me from it and encourages me to consider it impure. So each of these are traits that I want to be like, but which I feel like I have to suppress if I want to really be a good mathematician in the way that academia sees it. But even as I feel these, I still have hope that I don't really have to let go of any of them. I know that they're important to me. I have so many things I want to do that aren't math and aren't research. I want to read a lot of non-math books. I want to go on walks. I want to stay in touch with friends. I want to do physical work. But I think it's still possible for me to do all of this and still learn more math and maybe even write a thesis. I have a friend who is much more comfortable with academia language and attitude, and being friends with them does help me come to terms with these culture differences that I feel with academia. Namely, this friend likes math because they see it as a way of building more machines. They like the idea that you can build bigger machines and progress in math. They feel that it's worthwhile to think about interesting questions. But when we hang out together, we still have fun talking about math or about other things. I can sense that we have a lot of shared sensibilities, and I like spending time with them. So I know that it is possible for me to be in an academia setting and not have to give up everything that is important to me. I know I am not alone in having these feelings. I've met people who have made decisions to stay outside of academia, or people who've gone through academia but have a neutral experience with it. And it's partly because I know that I'm not alone in this that I wanted to share these experiences in this video. I think there is something that academia communities can benefit from hearing. It's that it's very good to have this kind of unified epistemological assumptions, this kind of respect for progress and for machinery, building machinery or whatever. But it can also be very beneficial to be more flexible about the language you use, about the values you have. I think there are some people who, like me or like Simone Weil or whatever, seek for a relationship in mathematics. And I think that can look very different from what is expected of mathematicians in academia. For me, it takes the form of searching for metaphors in math and ruminating on ideas. But I think doing these kind of silly things will have a lot of happy accidental consequences that will inspire many other areas. Just as a flower growing and flourishing will eventually spread its seeds everywhere, and those seeds can find a new home in many different soils, so too can unconventional relationships flower into works that might disperse into the soils of people who are working and need accessible math, for the soil of educators, for the soil of intellectuals in and out of math as well. I believe that the core of the issue, with some people feeling comfortable in academia and some people feeling awkward in it, comes down to the perception that the languages, values, and fantasy selves that are allowed into academia have a particular inflexible form. And I think that if you want to contribute to allowing the culture to be more accepting, a solution to the problems I talked about is very simple and can only be done at the individual level. Please try to get to know the people who don't seem to fit in. They have to work so much harder than you do to be able to have the kind of conversations you feel at home in. When you recognize that they are making an effort, try to reciprocate by learning about what kinds of conversations they feel most fluent in. Ask them the questions that come to your mind, and even if they don't provide you with the satisfying explanations that you are hoping for, keep searching for something to connect with them by. Every individual is at least as sophisticated as the sum total of human knowledge about your field. If it gives you any consolation for the effort you need to exert to do this, you can consider your process of getting to know them as being akin to the process you went through in becoming comfortable in your area of specialty. But please do not treat another person like they are a set of open problems to work at, because I can tell when you are judging me to be interesting or trivial. For academia to be good soil for lovers of wisdom, it must allow everyone to find roots in their own way. Because soil that has been home to just one way of life is prone to suffering from degradation. This is why Simone Weil says that the art of transposing truths is one of the most essential and least known. The art of planting diverse seeds in a homogeneous field is essential because it maintains the health of the soil. And it is the least known because it is not appreciated until there are poor harvests that result from its absence. I think there's also another way of looking at this. I think our greatest privilege is that just because we happen to become skillful at defending every point we have within some logical framework, and because we obey the proper decorum of intellectual culture, people listen to us. There are many people who are flat out ignored because they lack this privilege. I think there is a reason why in the US there seems to be a lot of distrust now for highly educated people. I think that distrust has to do with this intuition that a lot of people feel that there's not really anything fundamentally different about being highly educated. But somehow highly educated people get all the attention. People listen to you if you can put things down to words reasonably. And it's very hard to get that level of attention if you don't know how to do that. If there's anyone who has power to change these associations that people have toward highly educated people, it is these very highly educated people. And I think the best thing that you could do is to try to listen to someone even when they believe that the world is flat, or that you can square a circle, or that something is something, whatever it is, and that you listen without trying to convince them that they are wrong. It's okay to listen and not say anything. This is something I still have trouble doing sometimes, but I think I'm convinced of it. I think it's very possible to rebuild trust for highly educated people if highly educated people make an effort to make themselves more accessible to people outside of academia. I don't know what this will look like, and of course I have trouble with this as well. If there's someone who feels weird to me, then I find it very hard to give them attention. But as I understand it, the hope of people like Simone Weil or Francis Su is getting to learn to listen to people outside of this intellectual culture. Part of what it means to learn to read people and ourselves differently is to realize that being very reasonable does not mean that your point or your ideas are more valid than other people. Yes, it is good for things to be truthful, and the standards of intellectual culture are definitely built around the high standards for truth that have been developed over millennia. But everyone is a human, and nobody is doing anything fundamentally different. If you want any proof of this, just have a conversation with someone who's not from your school. I find that even when I don't talk with nerds, we can still have nerdy conversations. I find that when I give someone enough attention, eventually their brilliance starts to become more apparent. I think it is as true that we discover math as it is that we create it. And this is because math is someone who we can be a friend with. We discover our friends just as much as we create our friendships with them. And when we focus on one side of this coin over the other, attributing all of our joy to a discovery versus to all of the effort that we've put into our friendship, we become blind to the person who we are friends with in the first place. When we make the effort to listen to the friend who is right in front of us, we will realize that our tangible contributions do not matter as much as the entirely personal growth that has accompanied our pursuit of our relationship. In the same way, I think mathematicians and academians in general can benefit from letting go of this fantasy that things are pure. And I think maybe one of the easiest way to do that is by trying to listen when people are outside of academia try to have a conversation with you. Wow, it is dark out. Are you hungry? Oh no! Let's go get something to eat. Come on. You should have stopped me way earlier. Let's go find something fulfilling for both of us. I thought we were friends. I thought we had our own way of talking. I thought we had our jokes that could only be understood by us. I thought we used to walk to the convenience store together after school. I thought we used to spend hours at a time together in calls playing Minecraft. I thought we used to talk about our worldviews as we watched anime together. I thought we used to walk and skate around the city. I thought we went on errands together and you showed me the places you wanted to visit from Instagram. I thought we looked at ants carrying crumbs together. I thought we would stay like this. I met you when we were both a bit lonely, and it didn't matter that we didn't have other friends. I saw you when we were both trying not to give up on everything. I saw you when we were both trying too hard to grow up, and we were stressing from our own ambitions. I saw you when your illness was only a piece of your worries, and then a few months later, I got to climb a tree and jump into the ocean with you. I saw you when you feared him most, and then again when you realized you no longer feared him. You saw me when I hated everyone and myself, and when I was overworked and shattering, and when I cared so much about you that I didn't know what to do. Nobody can understand that. We were each other's family at some point. And yet, how can it be possible that I have forgotten you already? Has it not only been a few years? Weren't we so close that we had known that we had met by fate? Why do I care so much about math when what I really care about is you? Why do I still obsess over something so meaningless and think that what I am doing is discovering myself and my future? Why do I spend so much time in my head thinking about why I feel this way or that way about things that don't matter? What future am I trying to create if that future has already lost the most important part of my life? Am I really as horrible as to have forgotten you? How could I have forgotten you? Please forgive me, even if I have been unable to forgive you. I want to return to that time when we were walking around the city together, or talking together, or doing homework together, or eating together, or dreaming together about the things we wanted to have. I want to return to those moments when we were so focused on playing together that we did not think about anything else. I want to return to those moments when we were not strangers. And what am I doing now? I am prioritizing my work above all else. I am trying as hard as I can to ensure that my future is settled. This video betrays that there is something I cannot hold back, even amidst this lifestyle. I am dying to express this lament for my past, and my guilt for assuming that our friendship would last forever. I am ashamed, because even after all of this time, I still do not understand you. I don't know if I ever really put in the right effort. I make myself seem like I am very capable and interested in understanding and caring about you, when I don't really. There's a reason why you have become frustrated with how nice I am. It's because you have some intuition that I am much dirtier and self-interested than I make myself seem, but you can't figure out what it is. You want to push me away, and I keep coming back. I embed myself too close, way too close to comfort for your life, and you don't know what to do about that. I know this, and I don't change anything about it, and I imagine that you'll hate me even more for that. I still stay as I am, no matter how much you might want to scream at me to even notice you for a moment. I spend so much time doing so many things that don't matter. I work towards a future I don't care about. I tell myself I have fun and I really do enjoy the moment, but at the same time, I know that there will be nothing I really look back on and remember with gratitude if it is not for the people I love and my own humility in front of them. Everything I am doing is for nothing if all I do is stay inside my head at every moment, deliberating things that don't matter, and letting the blessings of getting to connect with another person disappear like mist. Every moment of my life is shameful because the moment I am no longer right next to you, or sharing the same hobbies as you, it is so easy for me to forget you. I know this, and I still forget you. I know that we will become different people, and we have already become such different people, and we have always been different people. I know that we have forgotten our language and our world that we have shaped together. And yet I don't do anything to fight against it. How can I keep doing this to you? How can I forget that it was so amazing in those moments to talk and share my life with you? How can I let myself believe this illusion that once our friendship has ended, it is no longer part of my life? It has ended, but it is still here with me. At any moment, if I am only willing to wonder and appreciate and love the person we were together. The nature of living is to become a stranger and to find that everyone else is a stranger to you. I want so much to cling to what I have known and trusted and believed in for so long. And yet it is not possible. For me to be alive, I must betray myself and everyone. The thing that made it possible for any of my friendships to form in the first place was betrayal. And for that reason, I am going to betray myself once more. I don't remember what I told you I wanted to be when I grew up. I probably said a lot of things to you. Most recently, I wanted to be a teacher of some sorts, and I knew that math was one of the soups that tasted delicious and comforting. I decided that I would do a math PhD and try to become a math professor. I am going to betray this dream because I have realized that I have been expecting the wrong thing. I expected to emphasize my independent intellectual journey in trying to become a professor. I wanted to spend time learning from students and other mathematicians, not because I cared about them, but because I cared about myself. I didn't ever admit this to anyone, but I believe that schools are intended as communities of learning, where everyone learns next to other learners. I did not care that even though mathematicians work best when they collaborate, I would be spending all of my time either preparing for classes in my room or writing on the blackboard, working on my own problems in my room. I did not care that I would have to fight long and hard to force myself to become something I am not. I was trying to force myself to get used to pouring my heart and soul into a project that only a handful of people in the world will be able to understand and appreciate, all of whom are too busy with their own projects to care or notice. I was trying to force myself to accept that I will primarily teach people who are enrolled at my school, and primarily talk to students who come to my office hours, and primarily spend my time socializing with people only as a professor. I never wanted to just be a professor, but I was trying to force myself to accept what I did not want, because I falsely believed that this was the only way to get what I wanted. I don't want this, and I don't want to force myself to want this. And so I'm going to give up on my dream, because I realize that this sleep is more paralysis than it is rejuvenation. And yet, I want to keep appreciating math. That much is honest. I find math so comforting, and I wanted to share it with others. And I really wish you could understand me when I say this. I want to share it with you. I feel so much joy when I see someone at any situation in their life exploring their curiosity as they play with patterns. I don't want to turn math into a tool, and I don't want to turn it into competition. If I will do something with math, it will be for the purely silly reason of playing with them. I will not force myself to get used to doing anything else with math. I want to play with math, and play with people through math. And yet, if I do not become a professor, then doesn't that mean I'm giving up this possibility of doing what I find so much joy in? I cannot see any possibility of getting to do what I want at this moment. But I somehow have faith that my close relationship with math will never end. Maybe I will end up being some kind of teacher in the future. Or maybe I won't. But no matter what I do, I have faith that math will always stick around with me. I will feel at times the sorrow of remembering that math was my close intellectual friend during college, and is no longer what it was anymore. I know that I am betraying myself and my math in deciding at this moment not to pursue this life. And yet, sometimes I remember you. Sometimes I wonder how you are doing now and what will happen to you. Sometimes I feel grateful that I got to know you and be so influenced by you, at least during that short moment in my life. Sometimes I don't want to talk to you ever again so I can remember the memories untarnished. Sometimes I want to talk with you again to relive the memories. But I know it won't be the same. Maybe it'll be better, or worse, or it'll tarnish the memories, or it'll add closure to them. Maybe nothing will happen. But sometimes I wonder what would happen if we were still together, talking and playing. And I know I would be a different person if that was the case. Sometimes I wonder if that will happen again in the future. But it feels too absurd to me. Am I going to stay as I am? Working hard on the things that make sense to me, and forgetting the things that don't make sense. Allowing myself to be changed by time with little to no resistance. Maybe. But I want to somehow say to you that I miss you at the same time that I fear you. And even though I am anxiously building memories upon a rapidly collapsing surface, I still love you. 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 I still